So I wiped the board clean 5 minutes ago, and I either created a masterpiece or something's going to jump out at me. That looks weird. Anyway, I'm not here for that. Let's pretend it's not there. Okay. It's nasty. Right, here we are. This new toy. Oh, yum. Look at that. My favourite one so far. Right, I'm going to get some spheres out of the way. Actually, before we get the spheres out of the way, let's get that out of the way. Alright, how does that look? Yeah. Alright, let's start sorting out what I'm messing about with ghouls. Okay. So we're here for the spheres, because we want to get to the inner core. We want to go and have a jump around inside the planet, because it's awesome. But first, we've got to do the spheres to get them out of the way, so we've got board space. So we've got 7 to deal with. The first one is the troposphere. It's the first layer of atmosphere, and it goes up to 10 kilometers. All right? So 10 Ks is 1 millimeter. So that 1 millimeter would have to be something like even thinner than that. It's crazy. That is the troposphere. That is where the CO2 is trapped, along with the storm moisture, all of the humidity and the moisture that could come up from volcanic eruptions. But it's just a different point of view, isn't it? A different perspective. But we'll delve into that as we go deeper, won't we, Planeta? Yep, so that's the troposphere. 10 Ks up, the first layer. That's where the action happens. That's where the planes fly as well. It's all that action-packed zone full of carbon dioxide that's killing the planet. Number 2, the stratosphere. That runs up to 35 to 40 kilometers. So that'll be that one there. That'll be about 4 mil. And then we've got, the stratosphere is more of a gap filler. I don't think it's got much to its name, but we will check up on that. Number 3, the mesosphere. So that goes up to 80 Ks. So that will be just under a centimetre. And this is the last layer where gas can do what it wants. After this, it kind of goes to the controlled environment where everything layers itself. Science. The thermosphere. Now we're jumping up to 550 Ks. And the thermosphere, it absorbs ultraviolet, apparently. It's an absorber of ultraviolet, so good for us. That runs at 550. Just below that, we've got the ISS, the International Space Station. Its orbit altitude is 400. So that's its orbit there. So when we see the footage or we see it overhead, it's like, wow. But when you look at that perspective, still clever. I'm not saying they're really good higher up, which is where we're going. Then we've got the ionosphere. It's to do with radio waves bouncing, and it reacts as well with the thermosphere. They do some magical stuff, protect us, good for communications, all the science stuff. And there, so that was number 5. And then number 6, the exosphere. 666, the exosphere. This is where the vacuum starts. This is where it gets good. 10,000 Ks. So that is a meter. So about there. Neil, put the brakes on. I am. That's when the vacuum starts. We're just having a bit of fun, we're not dissing. Okay, we're not dissing at all. The vacuum of space. There's no molecules or particles or atoms. Man, they're good, they're very good. And then, number 7, last but not least, the magnetosphere. That's to do with the core. It's iron and nickel. They reckon it's a solid lump. Because there's so much pressure, it can't be a liquid. That's what they say. I mean, a liquid cannot be compressed. Water can't be compressed, so if it can't be compressed, it can't be compressed. So does it compress into a solid? Anyway, so yeah, that's the magnetosphere, and it protects us with the energy, and it protects us from the sun's own weapons, like boom, boom, boom. Yeah, so that's the spheres, all right? So I reckon we'll scrub these out and maybe do a leap into the core.